Our strategy to go to the market starts with 0.2% of the market share, and if we can utilize all those resources in the US, we can go to 42%, and that's based on the assumption that we can use all available soy manure in the US. That's the cap. We cannot go more than that. Okay. Now, what we are doing right now, we are working on our pilot plant. Ellie was able to scale up the process from 1 liter to 1 gallon and then to the 4 gallon. But with that capacity, you cannot do anything, just provide samples. That's all we can do at most. So we talked to many engineering firms, and we found that there is some kind of mathematics going on here. You need to go a ratio of 15 to 20 to scale up the process. So we had an open bid for engineering firms for submission of proposals, how to scale up this from 4 gallon to 75 gallon, a larger reactor, which we call a pilot plant. You can design the process and show that it works outside the lab. So we received 8 proposals last week. So we are reviewing those, and we are trying to finalize the engineering firm who is going to work on that proposal. And everything goes well by August, at most 2014. You hear good news that it's up and running in the North Carolina farm. We have a farm there, it has 50 pigs, so the 75 is the size of their production. So input goes there, basically. And we can produce 75 gallon per day, and from that, we get 150 gallons Bio-Adhesive, and we get 5 pounds biochar. And biochar is the derived version of fertilizers. As you may know, some of the farmers use pig manure as a fertilizer. And this is a better quality product for them because it's solid and easy to transport from point A to point B. So actually they can use it. So that was something they wanted to use as a byproduct of our process as a fertilizer. If this goes well, we go to our first large commercial unit, which we had discussion with Murphy Brown, is a subsidiary of Smithfield, the largest hog production in the US. And that's a very large unit. It can produce 70,000 gallons per day and produces 5,000 gallons of Bio-Adhesive and produces 100 pounds of biochar. And the cost estimate we have is around $1 million. A few notes on the supply chain. The strategy is to locate or co-locate our reactor close to large farms because we can have reliable sources of material for our production. And the smaller farms bring their manure for tipping fee, which they do today. We were in the national, what was the name of that national? North American Manure Expo. You need to go there. That's fun. And we were told that the cost of transporting soy manure to the farmers is 1 cent per gallon per mile. So that's the typical charge for them. So we can charge them the same rate. So it doesn't matter for the small farmers if they bring to us or to other farmer. We charge them the same fee. And when we produce it, we have 2 directions here. The one direction goes to distributors for asphalt, and the other one is for companies that create value-added products. And we don't want to establish the supply chain or distribution channels. We can use their existing channels. So these could be our potential partners. For example, here, we have some discussion with one of those adhesive companies in the US, and they want to work with us on that application. So we have 2 different directions here, either for pavement or liquid asphalt distributors, or for value-added companies that create value-added products from this. Okay. At this stage, for the pilot plant, we need financing for $500,000, and we were very successful to generate around $200,000 from business plan competitions, non-diluted funding, no equity sharing involved, and we are looking for around $150 15K for building the first pilot plant in ANT campus. If that goes well, the Series A is around $2.5–3 million, and that is the commercial unit in Parast, North Carolina, around mid-2014, close to 2015. And in the meantime, we are applying for SBIR, STTR. These are federal programs that support innovation for small companies. Actually, we were fortunate to receive a letter from NSF director for STTR that they are going to fund this project. So we are receiving some funding from STTR. And we have a letter of intent from one of the asphalt companies in the US that they are willing to prepay 100,000 tons of asphalt for this. So that was something we need to finalize that for building the first commercial unit. Okay, a little about the team. I mean, Daniel is our technical manager, and he was working in this project with Ellie for the last 4 years. And Ellie is the assistant professor of pavement civil engineering, and I am assistant professor of technology management. And we have a great advisory team here. Let me show you the whole name first. I mean, Dr. Roy, he is an expert in asphalt. He has his own consulting firm. Tom is expert in financial management and financial planning. Dave is a second-generation hog farmer. He came with us to the North American Swine Manure Expo and helped us to connect with hog farmers. Sean is the director of sales in Seaboard Asphalt, and Dr. Rubner is a professor at MIT, expertise in material science. We have been featured in many national and local media outlets, Wall Street Journal, National Hog Farmer, and Better Roads. Those are a few of those. Okay, and we are Bio-Adhesive Alliance. Let's turn what stinks to it to what sticks tomorrow.